Remember, you can find me on YouTube. Just do a search for BJ Jeffries, spelled just like that. And then you see this icon right there. That one right there. That's how you know you're at the right place. So you can subscribe to my channel by searching my name here. Look for this icon, and I have a lot of videos that you can look through over various topics: high school, elementary, middle school, all of it. A model for a company's revenue for selling a software package is R is equal to negative 2.5 P squared plus 500 P, where P is the price in dollars of the software. All right, so let me highlight the letter P, and let's talk about what P represents. P represents the input. R represents the output. So if P goes into the function, R is what comes out. All right, so let's do a quick example of how we calculate using this function. So if my input is $5, so we're gonna work with the example, say for instance I have $5. I plug in a 5 everywhere you see a P. And if you do the order of operations, that's when we can start calculating. So we have negative 2.5 times 25 plus 2,500. Now I can multiply the negative 2.5 times 25, and that gives me a negative 62.5 plus 2,500. And since those signs are not the same, that means I'm really going to subtract. So after I subtract, I get 2,437.5. So that's literally $2,437.50. So if we set the software package to $5, their revenue will be $2,437.50. So when it comes to functions, just keep it simple. When a price goes in for this function, that means a revenue will come out. That's the main idea of this function. So with this function, there's other types of questions that we can ask. And one of them would be like, what price will maximize the revenue? So we have a function. Now we want to know what's going to maximize this function. So maximize is the key word. So this approach that we're going to look at is the most basic approach. So earlier we calculated the revenue at $5. Now we're going to look at some more values so that we kind of understand what happens if we were to do this like one value at a time. So we have price and we have revenue. Remember, price is the input, revenue is the output. So for $5, the revenue was $2,437.50. So what happens if we increase the price of the software package? So let's just say we set a new software package price to $10. So if I run everything back through that function, its revenue is now up to $4,750. But what if the software package was higher? So say for instance, we set it at $50. So as you can see, as the software package gets higher, we're noticing that the revenue starts to climb. So now at $50, we're talking about $18,750 of revenue. All right, what about $90? So at $90, now we're looking at $24,750 of revenue. At $100, revenue is now at $25,000. So at a price point of $110, the revenue is now $24,750. So let's keep going forward. Let's say $150. So at $150 price point, the revenue earned will be $18,750. And notice that the prices are now starting to drop. So if I jump all the way to $200, so if I set $200 as a price point, then I'll be back at $0 in revenue. All right, so let's take a look at this table. As you can see, I got some random values, $5, and I skipped around all the way up to around $200, and I looked at the revenue for each amount. The price was maximized when we hit $100. And the reason why we know it was maximized at this point is because now, if you look over here at the revenue, that was the highest amount. It reached a maximum amount of $25,000 when the price was set at $100. So to answer that question, $100 software package will max the revenue at $25,000. All right, so let's take a look at the table values. So as you can see, my price, those are my endpoints. And for every price point, there's a revenue that can be generated. So this is like the most basic way to figure things out. One value at a time, you can see the prices climb. And then from there, you can see what the max revenue is. But this isn't the best way of figuring this out. What if I told you there is a much more efficient way to figure this out? So let's take a look back at the function. R is equal to negative 2.5 p squared plus 500p. And remember, vocabulary is the key. The word maximize is very important. So when we say maximize, what we're really trying to figure out is the vertex. Remember, we're dealing with a quadratic right now, and the vertex of any parabola is either going to be the highest point or the lowest point of that parabola. So when we have something in standard form, we start with at least finding the axis of symmetry. X is equal to negative b divided by 2a. And b is represented by the 500, and a is represented by the negative 2.5. So when I substitute in my values, I'll have negative 500 in the numerator, then I have 2 times negative 2.5 in the denominator. All right, so if we do some calculations, I'll have negative 500 divided by negative 5. And when you divide a negative and a negative, you'll get a positive. So what we got here was 100. Remember, 100 is my axis of symmetry. So x is equal to 100. That's the same 100 that we got earlier, but we were only able to get it much quicker now, like in 2 steps. So remember, $100 will maximize the revenue. We still don't know what the max revenue is. And remember, the most basic way was a table of values. The only thing is, a table of values would take too long, especially if you have a lot of different numbers to figure out. So how can we skip past the whole table and jump straight to the number that we're looking for? That's why the vertex is important. All right, now that we know that the revenue will be maximized at $100, we can just insert the $100 into the function. So everywhere you see P, I now replace P with 100. And so following the order of operations, I do my exponent first, and I multiply by negative 2.5. So that gives me a negative 25,000. 500 times 100 is 50,000. And by subtraction, 25,000. So when x is 100, r is 25,000. What we found was the vertex of this parabola. That means now I know the max revenue. So to find the vertex of a parabola in standard form, let me put a box around. I'm circling the axis of symmetry. So we start by finding the axis of symmetry, and let me circle the second part. We substitute in the axis of symmetry once that we know it. So in 2 parts, we can get the vertex, which will let us know when something is either maximized or minimized, and you'll know the value. All right, so here's the function graphed out so that you can actually watch what happens with the prices as I go across the bottom. So this axis is the input axis, or the x-axis. That's the price. The y-axis, that's the revenue. So at $0, I have 0 revenue. As you can see here, I have 0 and 0 in the bottom corner. So when I get this in motion and I start going through the revenue, through the prices, as I climb, you'll start seeing the price goes up. Then it eventually start dropping back down. So that function is a quadratic because it did create a parabola. Now, if I were to look at the value, as you can see here, and I might have to zoom in on it, the max revenue happened at the very top. And there's your $100 as your input, and your $25,000 is the maximum revenue. So when you find the vertex, we're able to go directly to that special point without having to plug in number after number after number after number until we figure it out.